Okay, so today I'm going to be doing a review of topics from Unit 7, mainly because I was getting a lot of questions that were specific to the homework, and a lot of it seemed that key concepts from previous units were being overlooked. So I'm going to show you how to apply those to solve your homework problems. Okay, so a common one that I was getting questions about either dealt with osmotic pressure or Raoult's law. So before I even get into that, the Van't Hoff factor is something that a lot of you had trouble um, figuring out, and I want to clarify how you do it again. So the Van't Hoff factor is simply telling you how many ions you have in solution. So I'm going to take something simple like sodium hydroxide, which is a strong base. You find it in drain cleaner. So when you have sodium hydroxide in solution, you have two ions. So all this does is it splits the positive metal and it splits the hydroxide up, making it a strong base. So what happens is you have 1 plus 1. So I is equal to the amount of ions. So what this relates to is if you have a beaker of this stuff mixed in water, it's saying that you're going to have some Na plus and some OH negative, floating around in there. That would be why your I is equal to 2, because it dissociates completely. Compared to if you had something like methane, which does not dissolve in water because it's greasy and oily. If you had that in a beaker, it's just going to have two layers. It's not going to be, dissolving like an ion would. So the top layer is going to be your CH4, and then you're going to have some water. So the whole thing that I want to get across is for this, I equals 1 because it doesn't split up. Alright, some other examples. Say you had like magnesium chloride. When you split that up, you have Mg plus 2 plus 2Cl negative. So that's going to be 1 plus 2. So I equals 1 plus 2, or 3. Pretty much, like, you guys just need to be able to look at these ionic compounds and split them up. If it's organic, like this, or it's, unknown, you can just assume that it's 1 because we really don't know. So anyways, on to some problems. I'm gonna pull one off of the homework. This one was like one of the most common ones. So I'm gonna show you how I would work through it. So this problem says if 0.78 grams of sodium hydroxide are added to 1 liter of water at a temperature of 21 Celsius in a tube separated by a semi-permeable membrane, calculate the osmotic pressure of the solution. So again, when you do osmotic pressure, we're going to assume that we have like a U-tube or something like that. And then it's going to have a semi-permeable membrane in the middle. And let's just say our water is over here. And then we have our sodium hydroxide over here. So osmotic pressure is going to be the pressure from an outside source that prevents osmosis from happening. So right now, the water is going to diffuse through the semi-permeable membrane that the sodium hydroxide can't go through. And it's going to equalize, so there's even amounts of water on both sides. That's the whole idea. So we need to figure out what that osmotic pressure is. The formula for this was pi equals IMRT. And I think a lot of you were assigning more weight to these letters instead of just trying to break the formula apart. So we're calculating for pressure in atmospheres. And another formula that we've learned that does this is the ideal gas law. So you have PV equals nRT. Molarity is equal to N over V. So right here, if you were going to calculate this, you could write pi is equal to I N RT over V. So if you just ignore the I and put a P there, you kind of have the same thing. You're calculating for pressure in almost exactly the same way. So you already know what R is. It's that 0.0821 constant. Temperature is going to be in kelvins. And this is moles and liters, because molarity is mole over liter. So we're going to start by calculating this problem. So I'm going to erase all this stuff. Alright, so first things first is we have to figure out how many moles we have. One of the common things that I saw on the submissions were molarity was 0.78. Just don't do that. That's bad. Don't do that. Alright, so if you have a gram, like a mass amount of something, you have to convert it to moles if you're trying to find molarity. So sodium hydroxide, this is 22.99, and that's grams, that's 16, and that's 1. So you could either go with 39.99, which is what it adds up to, or you can just round it to 40. It doesn't really matter in the grand scheme of things. It's not going to change your answer by that much. So that would be the molar mass, which is another thing that I've been noticing you guys have kind of forgotten how to do. So if you forgot it, just remember when you have, like, you have 1 and then your atomic number or whatever. So whenever you're looking at the periodic table, that's your molar mass, which is also the atomic mass. So that number on the bottom is simply what you have to add up. And I'll leave you guys to do the algebra between all the chemical compounds, but like I don't know if it was just too long of a time from doing that, but you guys gotta remember that. It's super important. Alright, so we're going to, sorry, I lost my train of thought. So anyways, let's convert to moles. N equals 0.78 grams times 1 mole over 39.99 grams. So your grams cancel. Let me pull the calculator up. So you have 0.78 divided by 39.99. And your answer is going to be 0.0195, which that last decimal is kind of excessive, so you could just go with 0.02 mole. So now this next part kind of requires you to read into the question a little bit. Not much, but if you have 1 liter of solution and molarity is mole per liter, your molarity is going to be 0.02, because if you divide it by 1 liter, it's going to be 0.02. So that we have our M values. We're going to write all this stuff down. Alright, now, I already showed you how to do the Van 't Hoff factor earlier for sodium hydroxide. It's 2, but if you want to see it again, I'm going to split this up. So you have 1 and 1, 1 plus 1 equals 2. Alright, so our I value we have, R you should already know, and then T is 21 degrees Celsius plus 273 kelvins, which is 294 kelvins. And alright, we have everything that we need to solve this equation. So if you need to copy this, I'm going to take it to the next page to finish it. But alright, let's finish solving this. So now that we have everything, we just plug it in. Pi is equal to 2 times 0.02 m times 0.0821 liters times atmospheres over moles times Kelvin. So if you want to replace m, it's understood that it's moles per liter, but you just put mole and then you divide it by 1 liter, and then times 294 Kelvin. And then you're going to see that everything's going to cancel out. So liters is gone, moles is gone, and kelvins is gone. So let's plug this into the calculator and see what our answer is. 2 times 0.02 times 0.0821 times 294. So you should have gotten approximately 0.965, 0.97, whatever, it doesn't matter. 0.965 atmospheres. And that would be, in this problem, the amount of pressure that would be necessary to keep the water from diffusing across the membrane. So less than 1 atmosphere, so it shouldn't be diffusing if it's not in a closed system. Alright, so the next thing that I've been noticing was, we'll do a Raoult's law problem, because I had a few questions about that too. Alright, so this one. At a temperature of 27 degrees Celsius, the vapor pressure of water is 26.7 torr. So if you have 80 grams of HNO3 and they're added to 750 grams of water, what is the vapor pressure? So your question should be how do I put this in this formula? So it's super simple. The pressure of your solution is your mole fraction times your vapor pressure. So let me put that in the correct form. So our solvent is clearly water, and we have nitric acid. So we're going to need to get the moles of that. So to get nitric acid, we just add it up just like I just did. So HNO3. So 16 times 3 is 48. Plus 14 is 62. So should be about 63 grams per mole, I think. Yeah. So that should be about 63 grams per mole. And we have 80 grams of it. So let's figure out how many moles we have. So 80 gram times 1 mole divided by 63 grams. And this is for your nitric acid. So 80 divided by 63. So you're going to have about 1.27 moles. HNO3. That's important for later. Now, your mole fraction is equal to moles of solvent divided by moles of solvent, moles of solute. So it should be a relatively small number, less than 1, because it wouldn't make sense if it wasn't. Now, we have to figure out how many moles of water we have. H2O is 18 grams a mole. You have 750 grams of it, so you multiply it by the molar mass. So your grams cancels, and we're going to figure this out. 750 divided by 18, and that should be 41.7 or 41.67 moles. So this is for H2O, and then this is for HNO3. So we have everything that we need because this goes right there. That is a horrible arrow. Let me redo that. Not much better, but that's going to stay. So let's solve this. So we're going to use 41.67 divided by 41.67 plus 1.27. So if you want, you can use the actual values. Doesn't matter. It's not going to change the answer that much. So we're going to do 41.67 divided by parentheses 41.67 plus 1.27. So your mole fraction is 0.97. 0.997. That was a horrible 9. Let me redraw that. Alright, so we have everything that we need to plug into this equation and figure out what our pressure is going to be with the nitric acid. So, or the vapor pressure. So P solution is equal to 0.97 times 26.7. So your pressure, or your vapor pressure, should drop down to about 25.9 torr, which it drops down by 0.8. It's not a ton, but you can see the effect that has. Alright, so if you need to copy this, pause it. The other last thing I was noticing was from acids and bases. Alright, so let me open up a problem. I know that this is a new topic, but I think I know what I'm going to review on it to make it a little more clear. So we're going to do oh wow, that was a typo. I'll fix that. Which one can we do? Alright, we'll do this one. So, I noticed a lot of problems with the word, like there's a lot of problems with the word problems. Really, I think it's just you guys were having trouble reading into the question. So we're going to go over step by step how you would solve this. So the pH one is a no-brainer. The pH of a solution is equal to the negative log of the acid. So in this case, and just before I get into that, there's no such thing as a negative logarithm. What this is actually saying is -1 times log of whatever number. So if your calculator is saying something like syntax error, you're either using the minus button or it doesn't support you typing the negative in first. So you do the log and then you do the negative. Don't type in log of negative number. That's not the same thing. So now in this instance, because this is a strong acid, we don't have to do an ice table or anything. So H2SO4 would be 0.1 and we plug in negative log. So on the calculator, it's going to give us an answer. Negative log 0.1, and that would be a pH of 1. So that's a very strong acid. Now, if you had 23.7 milliliters, how do you figure out how many grams of solution you have? So I want you to take a second and try and figure it out. Now, if you can't, I'm going to show you how to do it. So remember, molarity is N over V, so it's mole over volume. I gave you both a mole and a volume. So you just have to plug everything in. Now that volume has to be in liters. So we're going to do this like this. 0.100 m equals N over, and let's find out how many liters that is. So 23.7. So you're essentially going to be dividing it by 1,000. So that's going to move the decimal place. So you're going to be 0.0237. And then that's liters. So, and then we can change this to mole over liter. So we're going to multiply by 0.0237 liters. 0.0237 liters. So our liters are gone, and we're in moles. So 0.02, let me erase that. 0.0237, and then that's times 0.1 mole is equal to N. So that would be like 0.00237 moles. But I'm going to just verify in the calculator. Sometimes my mental math is not that good. Alright, so N is equal to 0.00237 moles, and that's H2SO4 for sulfuric acid. So now the last thing to do is figure out the molar mass. Or you could do that at the beginning, doesn't matter. So that's 2, because it's 2 times 1. Sulfur is 32.06. And then oxygen is 16, so when you multiply it by 4, that's 64. So you add these together, and that's 34 plus 64. So you end up with 98.06 grams per mole. Or 98 grams per mole, doesn't matter. So let's multiply this by the molar mass to figure out how many grams, and that would be how you would solve this. 0.00237 moles times 98.06 gram over mole. So your moles are gone, and then we have our answer. So when it says answer, it's because it's using this, which is what I wrote down. Just trying to save time. So we would have 0.232 grams. 0.232 grams of sulfuric acid. And that would be your final answer. Really, like, the whole idea of this is to be able to read a problem and figure out how to approach it. None of these problems are too challenging mathematically. It's really just you have to read into it and find out what it's asking you. And that's how you should be able to solve any problem in, chemistry. So I have one more thing that I want to touch on, because a lot of you guys were like really confused as to what a logarithm was. And so a logarithm has a base, and I know I'm using like the wrong math stuff, but it doesn't matter. So log base b of a is equal to x or whatever. Or you could do, it doesn't matter what letters you use, it really doesn't. So in the case of the logarithm that we're using, you have log base 10 of whatever this is. So let's say we had log base 10 of 10, that would be 1. So let me give you another example that probably will make it a little more clear. So log base, and then this number is what is equal to this if it's the exponent of the base. So if you have 10 to the 1, you have 10. So if I put log base 10, 100, this would be 2, and 1,000 would be 3. So what this is telling you is, and then I'll verify this in the calculator. I know it's right, but just so you guys can see. So, where is that? 10. So we'll do 10,000 to show you. And then you could do this with any number. You're essentially using, it's a scale that figures out what the exponent is equal to for this number. Really what's important about this for chemistry is, because there's so many particles in a solution, it tells you how much more concentrated the lower pHs are and the higher pHs are in terms of hydronium or hydroxide. So the higher up you go, that means that this one is 10 times less concentrated than this, which is 10 times less concentrated than if it was at 0. So the lower the pH, the stronger the acid is, because it's got more hydronium in it. So the whole purpose of this scale is to show you that every time you go up a number, you're decreasing the concentration by 10-fold or 10 times. So when you go down, you're increasing it by 10 times. That's pretty much what I wanted you to get out of what a logarithm was, because a lot of you were kind of confused when I was talking about it when you came in to ask about it on Zoom. So I would suggest, if you need more help with a log, ask your math teacher. I can explain it, but really, like, all you need to know in chem is what exactly it's talking about in terms of your concentration in your acids and bases and your solutions. And then that's pretty much it for the review. If you have any more questions, come into the office hours and I can answer any questions.